Unbalanced forces pulling at an angle. So now what we've got is an overall force. So our forces are not balanced in every direction, they're unbalanced, which means that we're going to have to go and use Newton's second law, so some F equals ma stuff. So what we've got, our general situation is going to be an object on a flat surface, and we'll call the object 15 kilograms. And you're going to have a force pulling up at some angle. Let's call the force 200 newtons, and the angle, call it 25 degrees. These though will become a little bit more difficult because we're going to have a force of friction as well. The force of friction is always going to go in the opposite direction of your applied force, and your applied force is 200 newtons. We're going to look at the x component of that. We also have to look at the y component, because we're going to have to factor in that y component to figure out our normal, to figure out what the coefficient, or sorry, the value of the force of friction is. So I'm going to tell you that your coefficient of friction is going to be 0.15. And what we're going to do, I guess, is we're going to, as the question, we're going to find the acceleration of the object. So we're just going to find the acceleration. So I guess there's a whole bunch of things that we've got to look at. I'm going to still kind of stick with my blues for my x components, and I'll look at my y component here. I've got that one as well. I guess I've got I guess I'll mark it as a force due to gravity pulling this thing down, and a normal force pushing it up. But I'll actually just apply those two forces. So my two blues and my two pinks. So first thing I'm going to do is I'm going to find the normal force. So I'm going to find Fn. And Fn is going to be here. So in this situation, you have to look at whether or not the object is staying the same weight. So is it apparent weight 150 newtons? Or is this pink vector here making this thing appear to be heavier or lighter? And so since it's pulling up like this vector is going to make this entire thing appear to be lighter, which means my normal force is going to be less than what it would be without the angle, or the pulling at the angle. So this was not going to be 150, it's going to be 150 subtract whatever that is. What is this? Well, this is Fy. I guess I'll put my Fx down there while I'm at it. So I'm just going to put that. I'm going to write down that it appears lighter. Okay, so that is going to let you know then that to find our normal force, we're going to go mass times gravity, and we're going to subtract it from Fy. So my normal force then is going to be 150 subtract 200 sine 25. And when you plug that into your calculator, you get a normal force of 65.5 newtons. That is this, 65.5 newtons. So there's your normal force. It appears to be less than 150, which is what it would regularly be when you go mass times gravity. I guess, let's go with this here. So let's just look at this. This is my Fy component. My Fy component, when you plug in 200 sine of 25, you'll notice that in your calculator this thing is 84.5 newtons, and that's upward, so that's positive. This, you should just have a look. This 85 is your upward force, so that's actually this thing pulling it up. Now in the situation with this, it's not pulling it up enough to actually pick the block up off the ground. You know that because the actual weight is 150 newtons. That's your force due to gravity, which is more than the 84 pulling it up. So the thing's not going to leave the ground. So the only thing that the object's going to do is move to the right. So the object moves right only, and not up at all. So that means that this acceleration up here is actually going to be ax. That's what we're trying to find, because that's what's going to happen. The thing's going to move just to the right. So now I just have to worry about blues. To find my second point here, that is going to be to find my force of friction. which is kind of the whole point of finding my normal force. My force of friction is mu Fn. So my force of friction in this case is going to be my coefficient, 0.15 times it by 65.5. Plug that in, get a force of friction of 9.83 newtons. That will be in the negative direction because 9.83. Okay, it's in the negative direction, newtons. So let's see here. Now our third step, our final step, third, is going to be to find the acceleration. So really what I'm trying to find is AX. So you remember from probably like grade 1, maybe not that, maybe like grade 4, you're going to go F equals ma, except you're going to find Fx, and that's going to help you find AX. Well, that goes back to our sums. We're going to find the sum of all the x forces. So that means that I'm going to go with Fx here, and I'm going to have to subtract off my force of friction, and that's going to be equal to my mass times my AX. So let's see, Fx is 200 cosine of 25. I'm going to subtract that off of 9.83, and that's going to be equal to 15. Solve it for AX. When I do this, I'm actually going to solve it for AX. That'll end up being 200 cos 25. That's 181.3. Subtract 9.83. Divide that by 15. And my AX ends up being 11.43 meters per second squared. It's positive because it's to the right, going to the right. So I'll underline that. And I guess the last thing I could do, if you're ever asked to find it your acceleration in terms of g's or gravities, you would just divide this by what the value of gravity is. So I guess as like a separate answer, if they wanted to know the value in g's, this thing would be 1.143 g's if they asked it. And they probably won't. There you go.